this yet, just trust me. We'll get there. Madison, yes ma'am?
Isn't it kind of because Tavish has more force?
Absolutely. The resultant force is what we're looking to find. And that is where we're going here. We're adding the y, and I need to talk about Let's go down to these guys here. So I'm going to take this example. We're going to do an example of, think of the same thing here, but we're going to do it an example of Coulomb's law. So I'm going to use charges, and we're going to call this one two-dimensional analysis. Well, let's do this first. 2 dimensions. This one is a way we communicate where did I go? 2 dimensions of something along 2 perpendicular lines. What does this allow us to do? 2 dimensions, a way we communicate position of something by describing its position along 2 perpendicular lines. Excuse me.
You put it on a grid.
Okay, you put it on a grid is really right on the money. I'm looking for a particular thing right here. What is it? What's a grid? What do you mean by a grid? I don't get it.
X and Y graph.
An XY graph. You're absolutely right. And what do we know about the X and the Y axes? How are they relative to each other?
Perpendicular.
They're not just perpendicular, they are perfectly, absolutely. By definition of our axes, they are the epitome of 90.0000000000000 degrees. That is the definition that we've done. Why did we do that? Why did we make them perfectly perpendicular? It makes it easy because of some particular reason.
The relationship is always constant.
It is always constant and it is always independent. The motion along x is always independent of the motion along y. So that's what we're talking about here. And because of that, it allows us to define a position on a grid. But what is also a grid? What is a grid? It is a plane. Thank you, Bradford. That's exactly what I was looking for. Which allows us to position in a plane. In your other notes, you might want to say, such as the piece of paper I'm writing on. And we need to know that because now Kip Wanacelia came in and he hit those 2 and put them in motion along an axis that we have not yet defined. So we have to define this axis. So now let's go ahead and we'll draw out our axes here. And I'm going to get my straight edge. And let's go ahead and we'll give you an example here. Here's my grid. And what's a good way to do this? And we'll use the same example. We'll talk about Kip and Tavish. And let's do, how am I going to make this work here? We'll call, let's go ahead and do this. We'll do a Q1, and this will be my Q2. And we're going to say that these are negative, so I'll put some electrons around them. And then we're going to go ahead and we'll put a Q3 down here. And let's go ahead and we'll do, let's do positives here. So these guys will be positives.
Wait, where's Q3?
This is Q3 down here. Okay, go ahead and draw that example. It doesn't need to be perfectly to my exact scale, but I want you to see if you can figure out how to draw the independent forces. So think of it, just draw F1. Actually, let's draw these. Draw FE1, 3 and Fe3, comma 1. Are you able to see?
On,
Those are positives down here. All right, I want you to draw an estimation of F1, comma 3 and F3, comma 1. See if you can figure out what I'm talking about here. Fe is the force of the electrostatic force. Let me make that here absolutely right. You can't see it. This is 1.
Your little stand is kind of in the way.
Is that better? A little bit? How about this? Perfect. You can see everything now. This is number 2. And this is number 3. All right, I'm going to see. I'm going to come around and check your notes, see how we're doing here. Okay, I'm seeing people have drawn the diagrams. Nobody's gotten bold and tried to draw the force yet.
I did.
Ooh. Yeah, everybody try this. This is not easy. I'm realizing that this may not be as clear as it seems to me in my head. Kind of. Okay, I'm seeing that I recognize. Okay, I'm right. Good. Everybody try this. I'm gonna see where we are. Ooh. Okay. I'm glad that I'm going through this. I thought that this part was clear, but we need to go through it more slowly. Everyone, okay. There we're starting to get some ideas. I see Dylan's got it. Oh, okay, I'm getting some people. All right, let's do an example then. That will help. So I've got, are these two going to attract each other or repel? Attract, we know that. So so I could do the following. I could, I'm going to always have it say, it starts at the actual object, and I know it's going to be attractive. So does it make sense to connect the center lines?
Yes.
Because they're going in the same way. So I'm going to draw these. We'll say it is here, and then we'll say one of equal, and that is from the center point. I'm going to go ahead and draw that at 2 centimeters. And then from this center point, should I make it 2 centimeters as well? Should they be the same?
Yeah.
Yes, they should. So I'm going to label these then. This is F sub E, and this is acting on 1 by 2. So that's Fe sub 1 comma 2.
Comma 3.
You're absolutely right.
Yes.
Thank you. 1 comma 3. And then this is F sub E on 3 from 1. Okay, there I've given you an example. I want you to go ahead and see if you can draw the rest of them, which is F sub E. Let's do 2 or 1 comma 2. Go ahead and draw out the rest of these. I want to make sure you're getting it. 2 comma 1. And then we're also going to need to do Fe 3 comma 2 and Fe 2 comma 3. I think that's all of them. There should be 6 total, and there are. Okay, go ahead and figure out how to do the rest of these. Give me a straight edge there available. Notes there. Getting it. All right, apply yourself here. You're getting out of this what you put into it. Help, worse. Better? Same?
Same.
Put you guys to sleep here. Okay, I'm seeing effort out of most of y'all. See if you can draw the rest of them. See if you can do the rest of them. At this point, see if you can do the rest. I'm having you apply what we just talked about here. See if you can draw the rest of them. I've given you one example. I want to see 4 more arrows on everybody's notes here. Don't sit here idle. Apply yourself. Calder. There we go. That's what I'm talking about. All right. Those of you that are applying yourselves, you're doing well here. Those of you that are not applying yourselves, you're slowly getting behind. But let's move forward. I don't want to hold us up. Okay, Fe1 comma 2. It's the force acting on 1 by 2. Is 1 and 2, are they attracting or are they repelling?
Repelling.
They are repelling. So my forces, make sure you check this. Dylan, this is check your notes here. Because I saw a lot of people doing this backwards. This force goes outwards. We'll call it 2 centimeters here. I got 2 centimeters and 2 centimeters. I saw everybody that did it on their notes had these two back.